Hi, this is Maggie. In the last video we talked about a design for an online publication as an example of inheritance. In this video we'll continue to talk about that example. This is an association class diagram of our system. There's a page class with an aggregate relationship with content item objects. Content item is a superclass that might be specialized by subclasses, each representing a different kind of content. Here we imagine that there might be an article, ad, and image subclasses. We looked at an implementation of this that I called minipub because it has only the content item and ad classes in the inheritance hierarchy, and it's a very simple text interface with little behavior, so there's little reason for inheritance here. This is an example of how to subclass. We put the superclass name in parentheses in the class definition header of the subclass. We pass all parameters needed for both the superclass and subclass initializer into the subclass initializer, and then the first line in the subclass initializer is a call to the superclass initializer. We use the super function, super open paren, close paren, and then dot init to invoke the superclass initializer. We'll look at an example that does a little more now, with unique functionality in the subclass that overrides the functionality that's in the superclass, illustrating an advantage of inheritance. This is a graphical example of the publication program using pygame. If I run it, you can see that I have two content items, and I agree it's messy. I didn't want to write more code than I had to because I didn't want to make it too complex. But if I click in the window or in the top content item, which is of type content item, then nothing happens. But if I click in the ad, then it launches a page in my browser. So to go over some of the code briefly, I have a main function that creates a pygame window at the top and has an event loop at the bottom. The event loop handles the quit event and click events, and between those I create a content item object, an ad object, and a page object, and add the two content items to the page. This is basically the same as the minipub program, except my content item data is now surfaces, they're images. Again, to keep it simple, I didn't create an article type with text that I then render as an image, but that's how I would handle that in order to deal with resizing if I were creating a slightly nicer version of this. So my lorem ipsum text, it's just a picture of text. Now going back to the event loop, you can see that I send the XY coordinates of the click to the page object. It has a handle click method. So that's the event loop. I create the publication data, I draw it to the screen, and then when the user clicks, I send it to the page object to deal with it. Now let's look at those three classes, but let's particularly focus on content item and ad because that's the inheritance hierarchy. And what I want to talk about here is overriding methods and dynamic binding. So here's content item. Its data is a surface, an X coordinate, and a Y coordinate, all private. So remember that means that it's part of the implementation details of a content item and will be managed within content item methods. In init, we set the surface from a parameter and set X and Y to 0. There are then setX and setY methods, which set those fields to the parameter passed, and getWidth and getHeight methods, which return the width and height of the surface field. There's a draw method, which takes a surface to draw on as a parameter and draws the content item's data to that surface at its XY location. Then there's clickedIn, which returns true if the XY coordinate passed is within the frame of the content item's data, and false if it isn't. So that's just some bounds checking that the X coordinate falls between its left and right sides, and that the Y coordinate falls between its top and bottom. And now handle click. This is the interesting method. It might not look very interesting because the body of the method is the keyword pass. So in other words, it does nothing. How is that interesting? Well, consider this the default behavior for a content item when it's clicked in, to do nothing. Content, by default, won't react to clicks. And that brings us to the idea of overriding methods. Because in the subclasses such as add, if we want the subclass to respond to a click, then we can override this method. That means we use the same name, the same parameter list, the same return type, but we program a new method body. So we get new behavior. Let's look at that. Here's add, and it's really simple. It's a subclass of content item. It has an init, and this is a lot like the add class in Minipub. It gets the surface and a URL as parameter, and it invokes the superclass initializer and sends it the surface because that's the content item's business. And it sets the URL field to the URL. But it also has a handle click method with the same exact signature, name, parameter list, and return type as the content item handle click method. This handle click overrides the content item's handle click method. And in this handle click method, we open the URL field in the default browser. So in a minute, we'll talk about what happens dynamically when a handle click message is sent to an object. But let's finish going over this static structure. And from a design standpoint, what you can remember is that if you have a subclass of a class and you want to specialize some behavior, you override the method with that behavior and write the new behavior in the subclass method. If I needed to, I could call the superclass handle click method from within the subclass handle click using super open paren close paren dot handle click, just as I do in the init method. But in this case, the superclass handle click does nothing, and we don't need to call it. Page is our last class here, and this has a list of content item objects as a private field, again, like the Minipub example. And it has an add item method, like the Minipub example, which just adds a content item to its list of content. Then it has a draw method, and this iterates over the list of content item objects, does a little bit of math to figure out where to put them so they don't overlap, and then sends them the draw message. Remember, here's the content item draw message up here in content item. So hold on to that thought a moment. Remember that add doesn't have a draw method. And then page has a handle click method. Remember, this is called down in the event loop. And what page does is it asks each object in its list of content if it was clicked in. And if it was, then it asks the object to handle the click. Okay, so again, remember that clicked in is part of the content item class, and handle click is in the content item class where it consists of pass, and it's overridden in the add class. So if we look at the main function, we can see that page has two content item objects, an instance of content item, which is that lorem ipsum text, and an instance of add, which is the add for Niagara Falls. So let's talk about what happens when the user clicks in the window. The user clicks. Down in the event loop, we pull the X and Y coordinate out of the event and send them as arguments to the page handle click method. Up in page.handleClick, we iterate through the list of content items. I have the code for content item in self.content. The variable content item is what is termed a polymorphic reference. That's a word you can use to impress your friends. Polymorphism, the ability to have several different forms. And it's called that because the first time through the loop, when content item takes on the first object in the content list, it's an instance of content item. It's the lorem ipsum content. But the second time through the loop, it takes on the second object in the content list, and that's an instance of add. So a polymorphic reference is declared to be of the superclass type. You can see we've annotated it to be of type content item. But because an add is a content item, because it is a specialization, a subclass, a derived type, the polymorphic reference content item can also reference an object of type add. Okay, so that's a polymorphic reference. That's how the page class can never know what kind of object it's actually dealing with, which allows us to continue to build on this system and extend the content item class with different subclasses, extending the functionality of the system without having to make any modifications to the page class. Now it sends two messages. So let's get back to the first object, the lorem ipsum object of type content item. It's sent the clicked in message, and if the click falls within its frame, it's sent the handle click message. No problem, both of those messages are defined in content item. But what about if we get to the second object, the add object? There's no clicked in message in add, but really there is, because add is a content item. It inherits the whole public interface, so we can send add any public message that's defined in content item. So when the clicked in message is sent, the code that's defined in content item executes. But what about the next message, handle click? Well, we overrode that in add. So what happens is, when Python sees it has an add object, it figures out which code to execute, the handle click in add or the handle click in content item. Because it's an add object, it executes the code that was written in the add class. When it's a content item object, an instance of content item, it executes the code defined in content item. That's called dynamic binding. It means that Python decides at runtime, or dynamically, which code to bind to a method call. So if you have an inheritance hierarchy and a polymorphic reference that can reference any object in the inheritance hierarchy, Python won't know until runtime what the class of the object is. It can be any object that is that type. So in this case, any object that is a content item, including content item and add, and if we extend it further, any new subclass. So at runtime, Python looks at the type of the object and calls the correct code, binds the correct code to the call at runtime based on the actual type of the instance. That's why when we click on lorem ipsum, which is a content item object, nothing happens. Pass. But when we click on the picture from Niagara, which is an add object, the URL opens in the browser because the code defined in the add object executes. So this might take some practice to get used to, first understanding and then designing using this concept. I recommend running this code in the debugger and watching which code executes in response to clicks in different locations. And then you can add your own methods to the content item and add classes. You can change how objects respond to a click by writing a new set of methods, or you can respond to key press events. When you can extend the system in a way that includes dynamic binding, you're ready to move on.